When people hear the word light mentioned in conversation, they typically think immediately of brightness, vibrant color, or incredible speed. Something remarkably fast, something completely weightless, something that doesn't quite behave like the ordinary physical objects we interact with daily. That instinctive understanding is actually quite close to the fundamental truth, but it misses the deeper, more profound role that light plays throughout the entire framework of physics. Light is not treated or understood as a material object moving through space like a thrown stone or rolling ball. Instead, it is fundamentally understood as a way that energy travels from one location to another across vast distances, and the precise moment you begin to take that perspective seriously, light stops being mysteriously special in some mystical sense and starts obeying the exact same accounting rules and conservation laws as absolutely everything else in the universe. The first crucial point to grasp firmly is this essential fact. Light possesses no rest mass whatsoever. But simultaneously, it does carry both energy and momentum through space. Those two seemingly contradictory facts, taken together, explain nearly everything that initially seems strange, paradoxical, or counterintuitive about light's behavior. Momentum is frequently associated with heavy, massive things in our everyday experience: cars speeding down highways, balls flying through the air, planets orbiting through space. But in rigorous physics, momentum fundamentally depends on energy content and motion through space-time, not just on mass alone as a single factor. Light moves at the absolute fastest speed allowed by the laws of nature anywhere in the universe. And precisely because of that extraordinary motion, its energy automatically comes packaged with momentum as an inseparable consequence. When light hits a physical surface and reflects away, the surface experiences a genuine force pushing against it. The force is incredibly small and subtle, but it is absolutely real and measurable. Sensitive instruments can measure it with precision. Spacecraft designs must account for it in their engineering calculations. Something without any mass whatsoever can still push and exert force. This already reveals something profoundly important about the nature of mass itself. Mass is not simply how much stuff there is in some naive sense. In rigorous physics, mass measures resistance to acceleration, how hard it is to change an object's motion, and how strongly something interacts with gravitational fields around it. Light cannot slow down or speed up under any circumstances. So the concept of resistance to acceleration doesn't apply to it in the usual straightforward way. But gravity still affects light dramatically. Light bends when it passes near massive astronomical objects like stars and black holes. Stars and entire galaxies change its path through space-time. This happens not because light secretly has some hidden mass, but because gravity is not simply a pull on mass as Newton originally thought. Gravity fundamentally describes how space and time themselves are shaped and curved by energy and matter. And absolutely anything that moves through space and time must follow that geometric shape, that curvature, light included without exception. That understanding leads to a much deeper connection between seemingly different concepts. Mass and light are not opposites or fundamentally different categories. They are simply different ways that energy manifests and shows up in our universe. Mass is energy arranged and organized in a form that can remain at rest, that can stay in one place. Light is energy that cannot ever stop moving, that must always travel at light speed. When ordinary matter emits light, it loses a tiny amount of mass in the process. When matter absorbs light from its surroundings, it gains a correspondingly tiny amount of mass. This is not a poetic metaphor or loose analogy. It is a precise, measurable physical effect predicted by Einstein's theory and confirmed repeatedly by careful experiment. The amounts involved are usually far too small to notice in everyday situations, but the exchange is mathematically exact and perfectly balanced. Seen from this perspective, light becomes considerably easier to talk about and understand clearly. It is energy moving freely through space with absolutely no option to slow down or stop. And mass becomes energy arranged in a stable form that can stay put in one location. Both concepts follow exactly the same fundamental rules and conservation laws. They differ not in their basic nature, but simply in how that underlying energy is allowed to behave and interact. And accepting that mass and light are both manifestations of energy existing in different forms naturally leads to a more basic, fundamental question that demands our attention. What is light itself at the deepest level? At the most fundamental level of understanding, most people naturally start with an intuitive mental picture. Light feels like something tangible that travels from place to place, almost like an invisible stream or flow. That mental picture works well enough for practical purposes like turning on a lamp or aiming a flashlight beam. But physics demands something considerably sharper and more precise. In physics, light is not defined by brightness or color as we perceive them. Those are subjective experiences produced by our eyes and visual cortex. Light is rigorously defined as an electromagnetic disturbance, a changing pattern in electric and magnetic fields that carries energy and momentum through space without requiring any material medium. That phrase sounds abstract and technical, so it helps tremendously to ground it in something familiar from everyday experience. Think carefully about a calm lake. If you drop a stone into the water, creating a splash, nothing physical actually travels from the center of the splash to the distant shore. The water itself mostly stays where it is, oscillating up and down. What moves outward in expanding circles is the disturbance itself, the changing height and motion of the surface. Light behaves in a surprisingly similar way, except the underscore, quote, underscore two, underscore, is the electromagnetic field permeating all of space, and the disturbance moves through empty space itself. Space in modern physics is filled everywhere with electromagnetic fields. These fields are not made of material substance. They are properties assigned to every single location in space. Just as temperature can have a specific value everywhere throughout a room, electric and magnetic fields have definite values everywhere in space. Light appears when these field values change over time in a linked, coordinated way. A changing electric field produces a magnetic field. A changing magnetic field produces an electric field in turn. Those changes sustain each other in a self-perpetuating dance and propagate forward through space. That traveling wave pattern is what we call light. Nothing physical is being carried along like a thrown object. What moves outward is the change itself, the disturbance propagating. This already challenges our everyday common sense in fundamental ways. Everyday experience trains us strongly to expect that motion must involve physical objects moving. Light forces physics to deal with motion without the transport of any matter whatsoever. That is precisely why light does not need a medium to propagate through. Sound needs air, because sound is literally the motion of air molecules vibrating. Light is motion of fields, and the electromagnetic fields are already present absolutely everywhere in space. Now, intuition usually pushes back strongly at this point and says, quote, 3. That instinct is not entirely wrong, but it needs significant refining and clarification. Light is often described in terms of photons. A photon is not a tiny glowing bead flying through space like a microscopic bullet. A photon is the smallest possible unit of electromagnetic energy that can be exchanged in any interaction. It becomes relevant and necessary when light interacts with matter. A famous experiment makes this absolutely unavoidable. The photoelectric effect. When light shines on a metal surface, electrons can be ejected from the surface. Classical intuition predicts confidently that brighter light should knock electrons out more easily, regardless of the light's color or frequency. That prediction fails completely. Careful experiments show that if the light's frequency is too low, absolutely no electrons come out at all, no matter how intense the light beam is. Increase the frequency past a certain threshold, and electrons appear immediately, even at very low brightness. This behavior makes sense only if light transfers energy in discrete packets or bundles. Each photon carries a specific amount of energy determined entirely by its frequency. If that energy quantum is too small, no amount of piling photons together helps overcome the threshold. Common sense expects gradual buildup of energy. Nature does not allow it here. That experiment forces an unavoidable conclusion. Light behaves as packets of energy during interaction with matter, but light also spreads out, bends around obstacles, and interferes with itself. These are behaviors that perfectly match waves. The same phenomenon shows wave behavior during travel and particle behavior during exchange. That is not a contradiction or paradox. It is a limitation of our everyday categories and concepts. At a deeper level, light is described as a quantized excitation of the electromagnetic field. The field can only change by certain specific allowed amounts. Light corresponds to those allowed changes moving through space. Now mass enters the picture again from a different angle. Mass appears when energy becomes locked into arrangement that can persist over time. Electrons bound to nuclei, fields tied together, motion constrained. That trapped energy behaves as mass. Light represents energy that is not trapped in any way. This explains why light has no rest mass. Rest mass is defined as energy present when an object is not moving. Light cannot meet that condition. There is no reference frame in which light stands still. The idea of rest simply does not apply to light. Because of that, light always travels at the same speed, not because it is pushed and not because it chooses that speed, but because electromagnetic field equations permit only one speed for self-propagating disturbances. That speed is built into the fabric of space and time. This challenges another deep intuition. Speed usually depends on how hard something is thrown or pushed. Light ignores that rule entirely. This is also why light defines the maximum speed anything can have. Objects with mass must be able to slow down or stop. Light cannot. That difference fundamentally separates matter from radiation. Color now fits naturally into this framework. Color corresponds to the frequency of the electromagnetic oscillation. Higher frequency means higher energy per photon. Lower frequency means lower energy per photon. The energy of light is tied directly to how rapidly the field changes. This explains why ultraviolet light can damage cells and cause sunburn, while radio waves cannot, even if the radio waves deliver more total energy. Each ultraviolet photon carries enough energy to alter chemical bonds. Radio photons do not. Common sense expects total power to matter most. Physics shows that how energy is packaged matters just as much. Another famous example reinforces this: gravitational lensing. Light bends as it passes near massive objects, not because light has mass, but because gravity shapes space and time. Light follows that shape because it always follows the geometry of space-time. Photographs of distant galaxies warped by gravity confirm this behavior directly. Light responds to gravity even without mass. That fact forces physics to abandon the idea that gravity is simply a pull between masses. It is something deeper. Light can push because momentum comes with energy and motion. Light bends because space-time guides all energy. Light carries information because fields can vary in organized ways. Light heats objects because energy transfer alters atomic motion. No special rules are required just for light. It follows the same accounting as everything else. Light is energy in its most mobile form. It cannot remain still, cannot gather into stable structures, cannot pause. Mass is energy arranged in forms able to persist. Both arise from the same underlying quantity, governed by the same rules, behaving differently because the universe permits them different modes of existence. Understanding light this way removes mystery without removing wonder. It becomes one of the cleanest examples physics offers of how energy, mass, space, and time belong to a single connected system. At this point, light stops being just something that lets us see and starts becoming a guide to how reality is organized. Because light does more than move energy, it sets limits. It defines connections. It tells space and time how they are allowed to behave. One of the most surprising consequences is this: light determines what can influence what. In everyday thinking, cause and effect feels simple. Something happens, then something else responds. Distance just means delay. Farther away means later. That intuition works well for walking across a room or throwing a ball. Light exposes where that intuition breaks. Nothing that carries energy or information can act faster than light. Not because light is special in a sentimental way, but because it represents the fastest way any physical influence can move through space and time. Light draws the boundary between what can be causally connected and what cannot. This has a concrete meaning. An event can only affect another event if light has time to travel between them. If it cannot, then no physical signal, no force, no message can bridge that gap. This limit is not about technology or engineering. It is built into how electromagnetic fields and space-time behave. That boundary shapes the structure of time itself. Events are not simply ordered by before and after in an absolute sense. For distant events, the order can depend on motion. What remains fixed is causality, whether one event can influence another. Light sets that rule. This is why light sits at the center of relativity without being introduced as an extra idea. Relativity does not say light is special, so everything must obey it. It says the rules of space and time are such that light emerges as the universal speed that everything agrees on. Common sense expects time and space to exist first with light moving inside them. Physics finds the opposite. Light reveals how space and time are stitched together. Another implication follows directly from this. Because light carries energy and momentum, but has no rest mass, it shows that mass is not the fundamental currency of physics. Energy is. Mass is one way energy can appear. Light is another. This relationship is captured exactly in the connection between mass and energy. When matter emits light, its mass decreases. When matter absorbs light, its mass increases. This is not an analogy, it is a measurable fact. Nuclear reactions make this visible on large scales. But the same exchange happens whenever light is involved, even in ordinary processes. This forces a revision of how substance is understood. Objects feel solid, permanent, self-contained. Light feels fleeting. Physics shows that both are arrangements of the same underlying quantity. The difference is not what they are made of, but how long the arrangement can last. This leads to a result that feels strange at first. Empty space filled with light has inertia. A box filled with light weighs more than the same box without it. The difference is tiny, but it exists. Energy contributes to gravity regardless of whether it appears as mass or radiation. That result is not intuitive. Common sense expects weight to come from matter. Light refuses to cooperate with that expectation. Another deep consequence appears when information enters the discussion. Light is the primary way information moves through the universe. Every image, every signal, every measurement relies on light or electromagnetic radiation in some form. That is not an accident. It follows from the fact that electromagnetic fields can change in structured ways and carry those changes across space. This means information is physical. It is not abstract. It has energy costs. Sending a message requires energy. Detecting a signal requires energy. Even learning something leaves physical traces in matter. Light connects information to energy in a way that cannot be separated. This connection also explains why observation matters so much in physics. To observe something is to exchange energy and information. Light is almost always involved. Observation is not passive. It is an interaction governed by the same rules as everything else. This removes a common misunderstanding. Physics does not say reality depends on human awareness. It says reality depends on physical interaction. Light makes those interactions possible across distance. There is also a deeper unity hiding here. Light obeys quantum rules when exchanging energy. It obeys relativistic rules when moving through space-time. It obeys classical rules when large numbers of photons act together. The same entity connects three major frameworks of physics without changing identity. That alone is remarkable. Many ideas in physics appear to belong to one domain or another. Light refuses to stay confined. It forces theories to agree with one another or be discarded. Any serious description of nature must make room for light behaving consistently across scales. This makes light less like a topic and more like a test. If a theory mishandles light, something is wrong. Finally, there is a conceptual implication that is easy to miss. Light shows that the universe is not built from objects alone. It is built from relationships, constraints, and allowed motions. Light is not a thing traveling through space so much as a way space and time allow energy to move. That idea changes what existence means in physics. To exist is not only to occupy space, it is to participate in the rules that govern change. Light participates fully. It carries energy, momentum, information, and influence. It connects distant regions of the universe while obeying strict limits. It reveals that those limits are not obstacles, but the structure itself. Seen this way, light is not mysterious. It is honest. It tells us exactly how far causes can reach, how energy can travel, and how space and time cooperate to make events possible at all. Understanding light deeply is less about learning new facts and more about accepting that the universe is organized by rules that feel unfamiliar yet remain consistent everywhere. So after all of this, it's worth asking what picture of the world actually remains when the details settle. Light in physics is not a special case and not an exception. It is a reference point. It shows how energy behaves when it is free to move, how space and time respond to that motion, and how limits arise naturally from the structure of the laws themselves. What we know with confidence is this: light is an excitation of the electromagnetic field. It carries energy and momentum. It always moves at the same speed because the equations that describe the field allow no alternative. It has no rest mass, yet it responds to gravity because gravity governs space-time, not just matter. It transfers energy in discrete units during interaction, which explains experiments that classical intuition could not. These statements are not speculative. They are supported by measurement, technology, and repeated observation. We also know that mass and light are not separate categories of substance. They are different behaviors of energy. Mass corresponds to energy arranged in forms that can persist. Light corresponds to energy that cannot be held still. Both contribute to gravity. Both obey conservation laws. Both belong to the same accounting system. From this, a coherent worldview emerges. The universe is not primarily built from objects. It is built from fields, energy, and constraints on how change is allowed to occur. Objects appear when energy becomes organized in ways that last. Light appears when energy moves freely through fields. Space and time are not passive backgrounds, but active parts of the system determining how motion and influence are permitted. This worldview removes several common misunderstandings. Light does not travel through nothing. It propagates through fields that are already present everywhere. Light does not behave strangely. It behaves consistently under rules that differ from everyday experience. Light does not blur physics. It forces precision. It also clarifies what we do not yet know. We do not know why the electromagnetic field exists in the form it does. We do not know why the constants that determine the speed of light have the values they do. We do not yet have a complete theory that unifies light's quantum behavior with gravity at the smallest scales. These are active areas of research, not settled matters. But the gaps are bounded. They do not undermine what has already been established. Any deeper theory must still reproduce the behavior of light exactly as observed. The rules light follows are not optional features of reality. They are constraints any explanation must satisfy. When people hear underscore, quote, underscore, for, underscore, they usually picture two completely separate ideas. Space feels like the stage where things sit. Time feels like the clock that ticks while things happen. That picture works well for daily life, and it feels natural because experience trains us to think that way. Physics began with the same picture. Early scientists treated space as a fixed grid and time as a universal rhythm. Events took place somewhere, and they happened at some moment. The two ideas stayed politely separate, like coordinates written in different columns. Then careful measurement started to whisper that something deeper was going on. Light turned out to behave in a very peculiar way. No matter how fast an observer moved, light always traveled at the same speed. Walking toward a beam, chasing it in a rocket, standing still on Earth, every measurement agreed. That single fact forced a quiet revolution, because speed connects distance and duration. If the speed of light stays fixed, then distance and duration can no longer stay independent. Space and time began to lean into each other. Imagine describing an event. A flash appears, a bell rings, a particle decays. To locate that event, one must give both a position and a moment. Physics discovered that these two pieces of information blend together in a precise way. Change the motion of the observer, and the split between distance and duration changes while the combined description stays consistent. That combined description receives a single name: space-time. Space-time treats every event as a point with 4 numbers attached to it. 3 describe where, 1 describes when. The surprising part lies in how these numbers relate. Different observers may disagree about distances and durations, yet they agree about the space-time separation between events. Something deeper than space alone or time alone holds everything together. This explains effects that once sounded like paradoxes. Moving clocks tick differently. Lengths measured along the direction of motion change. None of this comes from faulty instruments or strange materials. It comes from space-time itself, assigning different slices of distance and duration to different observers. A useful way to picture it involves paths. Every object traces a path through space-time called a world line. Standing still in space still means motion through time. Moving faster through space tilts that path, trading some motion through time for motion through space. All objects move through space-time. They simply choose different directions within it. This single idea replaces many separate rules. Instead of asking how space behaves and how time behaves, physics asks how space-time behaves. Motion, light, cause, and effect all follow from that geometry. Once this viewpoint settles in, the universe begins to look less like a stage with actors and more like a woven fabric where events, motion, and measurement share the same structure. The fabric keeps its own order, quietly guiding everything that happens within it. Once that idea settles in, another shift follows almost automatically. Motion stops being something measured against a fixed background. Instead, motion becomes a comparison between different paths through space-time. Two observers moving differently are not arguing about reality. They are slicing the same space-time in different ways. This is where time stops being universal. There is no single master clock ticking for the entire universe. Each object carries its own time along its path. A wristwatch measures how much space-time that particular path passes through. That amount is called proper time, and it belongs to the object itself. Two observers can separate, move differently, reunite, and honestly report different elapsed times without contradiction. Space-time allows it. This sounds strange only because everyday speeds hide the effect. At human scales, the differences are tiny. At higher speeds, they grow. At the speed of light, something remarkable happens. Time along that path stops entirely. For light, there is no passage of time between emission and absorption. That fact is not poetic. It falls straight out of space-time geometry. Light traces the boundary structure of space-time. It marks the limit of cause and effect. Events outside that boundary cannot influence each other, not because of technological limits, but because space-time itself does not connect them in the right way. Cause and effect are not rules imposed afterward. They are built into the geometry. This also explains why simultaneity loses its absolute meaning. Two events that appear simultaneous to one observer may not appear simultaneous to another. There is no single answer to what is happening right now everywhere. Each observer carries a personal slice of space-time they call the present. The universe does not privilege one slice over another. Once this is accepted, space-time stops feeling abstract and starts feeling practical. Satellites orbiting Earth experience time differently from clocks on the ground. Their paths through space-time differ, so their clocks tick at different rates. Navigation systems must correct for this or they fail. The theory does not live in textbooks. It runs quietly inside technology. Then gravity enters a story, and space-time deepens again. Instead of treating gravity as a force pulling objects together, space-time describes it as curvature. Massive objects change the geometry around them. Paths that once looked straight bend, not because something pushes them, but because quote, _5_ itself has changed meaning. An object moving freely follows the straightest possible path through curved space-time. That path is called a geodesic. Falling, orbiting, drifting through space, these are all expressions of geometry, not force. Remove all other influences, and an object simply follows space-time shape. This explains why all objects fall the same way regardless of mass. They are not being pulled differently. They are following the same geometry. The motion comes from space-time itself. Time feels this curvature too. Clocks closer to massive objects tick more slowly than clocks farther away. Again, this is not mechanical stress or interference. It is geometry assigning different amounts of time to different paths. Space and time no longer act as separate players. They respond together. Mass and energy tell space-time how to curve. Space-time tells matter how to move. This mutual relationship replaces the older idea of forces acting across empty space. At this point, space-time begins to sound less like a background and more like an active participant. It expands, bends, stretches, and evolves. The universe does not sit inside space-time. The universe includes space-time as part of its physical content. Cosmic expansion fits naturally into this view. Galaxies move apart not because they fly through space, but because space-time itself grows between them. No central point is required. Every location sees the same pattern because the geometry itself changes. Even emptiness is no longer empty. Space-time can ripple. Gravitational waves are distortions that travel through it carrying energy and information. Detectors on Earth measure these ripples as tiny changes in distance, smaller than atomic nuclei, yet perfectly real. Space-time itself vibrates. At this stage, space and time stop being containers and start being relationships. Distances, durations, motion, gravity, and causality all emerge from a single structure. Learning space-time is not about memorizing effects. It is about adopting a new way to organize experience. Instead of asking, where is something and when does it happen as separate questions, space-time asks how events relate to one another, which events can influence which others, how much change fits along a given path, how geometry shapes possibility. Once seen this way, many puzzles lose their mystery. Slowed clocks, curved orbits, cosmic expansion, limits on signals, all follow from one consistent picture. Nothing special needs to be added. Nothing hidden needs to be assumed. Space-time does not explain everything, but it explains why so many things fit together so tightly. It provides a language where motion, gravity, and time speak the same grammar. Understanding that grammar makes the universe feel less strange, not because it becomes familiar, but because it becomes coherent. The fabric does not need intention or awareness. Its structure alone guides the unfolding of events patiently and precisely everywhere at once. Nothing physical actually travels outward from the center of that splash to the distant shore. The water itself mostly stays where it originally was, simply moving up and down locally. What moves outward in expanding circles is the disturbance itself, the changing pattern of the water surface height. Light behaves in a remarkably similar way to this, except that instead of a water surface, we're dealing with the electromagnetic field, and instead of the lake, the disturbance moves through space itself. Space in modern physics is understood to be filled everywhere with electromagnetic fields permeating everything. These fields are not made of any material substance we can touch. They are properties assigned to every single location in space. Just as temperature can have a specific value everywhere throughout a room at any given moment, electric and magnetic fields have definite values at every point in space. Light appears as a phenomenon when these field values change over time in a specifically linked, coordinated way. A changing electric field produces a corresponding magnetic field. A changing magnetic field produces an electric field in turn. Those changes sustain each other through mutual induction and propagate forward together through space. That traveling pattern of oscillation is precisely what we call light. Nothing material is being physically carried along like a thrown object traveling through air. What moves is the change itself, the disturbance propagating through the field. This understanding already challenges our everyday common sense in fundamental ways. Everyday experience trains us very strongly to expect that motion must involve actual physical objects moving from one place to another. Light forces physics to grapple with motion without any transport of matter whatsoever. That is exactly why light does not require any medium to propagate through, unlike sound or water waves. Sound needs air molecules because sound is literally the coordinated motion of those air molecules vibrating back and forth. Light is motion of fields themselves, and those electromagnetic fields are already present absolutely everywhere in space, even in perfect vacuum. Now, our intuition usually pushes back quite strongly at this point and insists, fine, but light still feels like a particle to me when I think about it. That instinct is not completely wrong, but it needs substantial refining and clarification. Light is often described using the concept of photons. A photon is definitely not a tiny glowing bead or marble flying through space like some miniature bullet. A photon is more accurately understood as the smallest possible unit of electromagnetic energy that can be exchanged in any interaction between light and matter. It becomes relevant and necessary when we consider how light interacts with material substances. A famous experiment makes this particle-like aspect absolutely unavoidable and undeniable: the photoelectric effect. When light shines on a metal surface under the right conditions, electrons can be ejected from that surface, knocked completely free. Classical intuition based on wave theory predicts confidently that brighter light, more intense light, should knock electrons out more easily and with higher energy, completely regardless of the light's color or frequency. That prediction fails utterly and completely when tested. Careful, systematic experiments show something very different. If the light's frequency is too low, if the color is too far toward the red end of the spectrum, absolutely no electrons emerge at all, no matter how blindingly intense you make that light beam. You can shine the brightest red light imaginable, and nothing happens. But increase the frequency past a certain critical threshold, shifting toward blue and ultraviolet, and electrons suddenly appear immediately, even at remarkably low brightness levels. This peculiar behavior makes sense only if light transfers energy in discrete packets or quanta, not as a continuous wave. Each individual photon carries a specific, definite amount of energy that is determined entirely by its frequency of oscillation. If that energy quantum is too small, below a certain threshold, no amount of piling photons together helps to free an electron. Common sense, trained on everyday experience, expects gradual buildup and accumulation of energy. Nature obstinately does not allow it in this case. That experiment forces an unavoidable conclusion upon us. Light behaves as discrete packets of energy during its interaction with matter. But simultaneously, light also spreads out in space, bends around obstacles, and interferes with itself in patterns. These are behaviors that perfectly match waves, not particles. The same phenomenon shows wave behavior during travel through space and particle behavior during exchange with matter. That is not actually a contradiction or logical paradox. It is rather a limitation of our everyday categories and concepts, which were developed to describe macroscopic objects. At a deeper, more fundamental level, light is described in quantum field theory as a quantized excitation of the electromagnetic field. The field can only change by certain specific allowed amounts, not continuously. Light corresponds to those permitted changes moving and propagating through space. Now mass enters our discussion again from a different angle and perspective. Mass appears in nature when energy becomes locked into specific arrangements that can persist over time. Electrons bound to atomic nuclei, fields tied together by interactions, motion constrained by forces. That trapped, confined energy manifests as mass. Light represents energy that is not trapped in any way, energy that is completely free. This fundamental distinction explains why light possesses no rest mass. Rest mass is defined precisely as the energy present when an object is not moving, when it sits still in its own rest frame. Light cannot ever meet that condition by its very nature. There exists no reference frame whatsoever in which light stands still. The very idea of rest simply does not apply to light. Because of that intrinsic property, light always travels at exactly the same speed in vacuum, not because it is pushed by something, and not because it somehow chooses that particular speed, but because the mathematical equations that describe electromagnetic fields permit only one single speed for self-propagating disturbances. That speed is built into the fundamental fabric of space and time itself. This mathematical fact challenges another deep intuition we carry. Speed usually depends on how hard something is thrown or pushed initially. Light completely ignores that rule. This is also precisely why light defines the absolute maximum speed that anything can possess. Objects with mass must possess the ability to slow down or stop completely. Light cannot. That difference fundamentally separates matter from pure radiation. Color now fits naturally and elegantly into this framework. Color corresponds directly to the frequency of the electromagnetic oscillation. Higher frequency means proportionally higher energy per photon. Lower frequency means proportionally lower energy per photon. The energy carried by light is tied directly and linearly to how rapidly the field oscillates. This mathematical relationship explains why ultraviolet light can damage biological cells and cause painful sunburn, while radio waves cannot harm us, even if the radio waves deliver more total energy overall. Each individual ultraviolet photon carries enough energy concentrated in it to alter or break chemical bonds in molecules. Radio photons do not carry sufficient energy individually. Common sense expects total delivered power to matter most. Physics reveals that how energy is packaged and delivered matters just as much as the total amount. Another famous example reinforces this understanding beautifully. Gravitational lensing. Light bends and curves as it passes near massive objects in space, not because light secretly possesses some hidden mass, but because gravity fundamentally shapes the geometry of space and time themselves. Light follows that curved geometry because it always follows the shape of space-time, without exception. Photographs of distant galaxies warped and distorted by gravity confirm this behavior directly and unambiguously. Light responds to gravity even though it has no mass. That observed fact forces physics to abandon the naive idea that gravity is simply a pull between masses. Gravity is something considerably deeper and more profound. Light can push because momentum naturally comes packaged with energy and motion. Light bends because space-time guides all energy without exception. Light carries information because electromagnetic fields can vary in organized, structured ways. Light heats objects because energy transfer alters the motion of atoms. No special rules are required specifically just for light. It follows exactly the same accounting principles as everything else. Light is energy in its most mobile, free-flowing form. It cannot remain still, cannot gather into stable structures, cannot pause even momentarily. Mass is energy arranged in specific forms that are able to persist over time. Both phenomena arise from exactly the same underlying quantity called energy, governed by the same fundamental rules, behaving differently simply because the universe permits them different modes of existence. Understanding light from this perspective removes unnecessary mystery without removing genuine wonder. It becomes one of the cleanest, most elegant examples that physics offers of how energy, mass, space, and time all belong to a single, connected, unified system. At this point in our understanding, light stops being just something that passively lets us see and starts becoming an active guide to how reality itself is organized at the deepest level. Because light does far more than simply move energy from place to place. It sets absolute limits on what is possible. It defines connections between events. It tells space and time how they are permitted to behave. One of the most surprising and counterintuitive consequences is this fundamental principle. Light determines what can influence what in the universe. In everyday thinking about cause and effect, the relationship feels straightforward and simple. Something happens first, then something else responds to it afterward. Distance just means delay in response. Farther away simply means taking longer to respond. That intuition works perfectly well for walking across a room or throwing a ball to someone. Light exposes exactly where that intuition breaks down completely. Nothing whatsoever that carries energy or information can act faster than light travels. Not because light is special in some sentimental or arbitrary way, but because it represents fundamentally the fastest possible way that any physical influence can move through space and time. Light draws the sharp boundary between what can be causally connected and what cannot be connected by any means. This has a very concrete practical meaning. One event can only affect another event if light has sufficient time to travel between them through space. If it does not have enough time, then no physical signal of any kind, no force, no message can bridge that gap under any circumstances. This limit is not about current technology or engineering limitations. It is built directly into how electromagnetic fields and spacetime behave fundamentally. That boundary shapes the structure of time itself in profound ways. Events are not simply ordered by before and after in some absolute universal sense. For events that are distant from each other, the order can actually depend on motion and reference frame. What remains fixed and absolute is causality, whether one event can influence another event. Light sets that rule without exception. This is precisely why light sits at the conceptual center of relativity, without being introduced as an extra assumption or special case. Relativity does not say light is special, therefore everything must obey it. Rather, it says the rules of space and time are such that light emerges naturally as the universal speed that all observers agree on. Common sense expects time and space to exist first as fixed backgrounds with light moving inside them. Physics finds exactly the opposite. Light reveals how space and time are stitched together into a unified fabric. Another implication follows directly and inevitably from this understanding. Because light carries energy and momentum but has absolutely no rest mass, it demonstrates clearly that mass is not the fundamental currency of physics. Energy is the fundamental quantity. Mass is simply one particular way that energy can appear. Light is another way. This relationship is captured exactly in the famous connection between mass and energy. When ordinary matter emits light into space, its mass measurably decreases. When matter absorbs light from its surroundings, its mass measurably increases. This is not a poetic analogy or loose metaphor. It is a precise, measurable fact confirmed repeatedly. Nuclear reactions make this visible and dramatic on large scales that we can observe, but exactly the same exchange happens whenever light is involved in any process, even in ordinary everyday processes at tiny scales. This understanding forces a fundamental revision of how we understand substance and materiality. Objects feel solid, permanent, self-contained to our senses. Light feels fleeting and insubstantial. Physics shows that both are arrangements of exactly the same underlying quantity, energy. The difference is not what they are made of fundamentally, but rather how long the arrangement can last and persist. This leads to a result that feels genuinely strange at first encounter. Empty space filled with light actually has inertia, has mass energy. A box filled with light weighs more than the exact same box without any light in it. The difference is incredibly tiny, almost unmeasurably small, but it genuinely exists. Energy contributes to gravity and inertia, regardless of whether it appears as mass or as radiation. That result is not intuitive at all. Common sense strongly expects weight to come only from matter. Light refuses to cooperate with that expectation. Another deep consequence appears when information enters the discussion explicitly. Light is the primary way that information moves through the universe over any distance. Every image we see, every signal we receive, every measurement we make relies on light or electromagnetic radiation in some form. That is not merely a convenient accident. It follows inevitably from the fact that electromagnetic fields can change in structured, organized ways and carry those changes across space. This means information is physical, not abstract. It is not something floating above physics. It has genuine energy costs. Sending a message requires expending energy. Detecting a signal requires absorbing energy. Even learning something leaves physical traces in the matter of our brains. Light connects information to energy in a way that cannot possibly be separated. This connection also explains why observation matters so profoundly in physics, especially in quantum mechanics. To observe something is to exchange energy and information with it. Light is almost always involved in that exchange. Observation is not a passive act of merely looking without interaction. It is an active physical interaction governed by exactly the same rules as everything else. This removes a very common misunderstanding about quantum mechanics. Physics does not say reality depends on human awareness or consciousness. It says physical reality depends on physical interaction between systems. Light makes those interactions possible across distance. There is also a deeper unity hiding here that becomes apparent. Light obeys quantum rules when exchanging energy with matter in discrete packets. It obeys relativistic rules when moving through curved space-time. It obeys classical rules when large numbers of photons act together collectively. The same entity connects three major frameworks of physics: quantum mechanics, relativity, and classical physics, without changing its fundamental identity. That alone is genuinely remarkable. Many ideas in physics appear to belong exclusively to one domain or another. Light refuses to stay confined to any single category. It forces our theories to agree with one another or be discarded as incomplete. Any serious comprehensive description of nature must make room for light behaving consistently across all scales. This makes light less like a specific topic within physics and more like a fundamental test of any theory. If a theory mishandles light, something is wrong with that theory. Finally, there is a conceptual implication here that is very easy to miss, but profoundly important. Light shows us that the universe is not built primarily from objects alone. It is built from relationships, constraints, and allowed motions. Light is not so much a thing traveling through space as it is a way that space and time allow energy to move and propagate. That idea fundamentally changes what existence means within physics. To exist is not only to occupy space at some location. It is to participate in the rules that govern change and interaction. Light participates fully and completely. It carries energy, momentum, information, and influence. It connects distant regions of the universe together while obeying strict limits that cannot be violated. It reveals that those limits are not obstacles or restrictions, but rather the structure itself. Seen from this way, light is not mysterious or magical. It is honest and straightforward. It tells us exactly how far causes can reach, how energy can travel, and how space and time cooperate to make events possible at all. Understanding light deeply is less about memorizing new facts and more about accepting that the universe is organized by rules that feel unfamiliar yet remain perfectly consistent everywhere without exception.